Hi students, welcome back to Smarter Everyday Overlearning. Dear students, in this session we are going to learn about the topic quantitative analysis, the estimation of phosphorus and the estimation of oxygen also we are going to learn in this session. Let's get into the class. In this estimation of phosphorus, a known mass of the organic compound is heated with fuming nitric acid HNO3 nitric acid in a sealed tube, that is only Carrier's tube. The structure of this Carrier's tube, here you can see, here entirely furnace is there, and here fuming HNO3 and 0.5 grams of AgNO3. This is the Carrier's method we have discussed already in the estimation of halogens, right? And this Carrier's method only you have to use for the estimation of phosphorus also. So here you can see the iron tube and organic compound. What you are going to test, the organic compound you have to take inside the Carrier's tube in a small test tube. Right, in this case carbon is oxidized into CO2 and hydrogen is oxidized into H2O. Right, coming to phosphorus, this is the sealed tube. Under these conditions carbon and hydrogen, these are oxidized into, I told you already, and while phosphorus present in the organic compound is oxidized to phosphoric acid. The formula is H3PO4. For suppose in that specific organic compound phosphorus is present, then that should be oxidized into phosphoric acid H3PO4, which is precipitated as ammonium phosphomolybdate by heating with concentrated HNO3. Again, this can be treated with concentrated HNO3 and then adding of ammonium molybdate. Now let's see all the chemical equations, what are the products and what are the reagents also. Let's see now. First of all, carbon. To this, if you add oxygen, here 2 moles of oxygen, this can be from HNO3, nitric acid. You can take this from nitric acid and heat gently, then CO2 will be formed. This is the oxidation process. Here, next equation, if you take in this way, just such a way only, if you take hydrogen, 2 moles of hydrogen, to this also if you add oxygen, this is also from HNO3, then if you heat this compound completely, then hydrogen will become into H2O. This is the oxidation process here. Such a way, phosphorus also, if you take 2 moles of phosphorus and to this 5 moles of oxygen, if you add, this is also from HNO3, if you heat this compound, P2O5 will be formed. If you dissolve this P2O5 with water, 3 moles of water, then again if you heat this compound, then students finally H3PO4 phosphoric acid will come here. Here the formed phosphoric acid, again formed phosphoric acid, the formula H3PO4, it should be treated with ammonium molybdate. The formula is NH4 twice MoO4. This is ammonium molybdate, and to this if you add nitric acid, and it is going to treat with nitric acid, and this mixture if you heat gently, then what is the final product? NH4 thrice PO4 12 MoO3. The name of this compound is ammonium phosphomolybdate. This is yellow colored precipitate, yellow colored PPT, okay, including with this plus NH4 NH4NO3 ammonium nitrate will be formed, including with water. Okay, and we should balance this chemical equation. Here in this ammonium phosphomolybdate, 12 molybdate ions presented. So if you place in front of this ammonium molybdate 12, the name of this compound is ammonium molybdate, and if you place here 12, then in this equation if you place here 21 and in front of this NH4NO3 also 21, and here 12 means here also 12 moles of H2O. If you place like this, then this equation is balanced now. So this is the balanced equation. Now the precipitates of ammonium phosphomolybdate, this precipitate thus formed are filtered, after that washed and weighed. Before weighed you need to dry it. Okay, filtered, washed, dried and weighed. Alternatively, phosphoric acid is precipitated as phosphoric acid. For suppose, let's see this equation. To this phosphoric acid H3PO4, if you add ammonium chloride NH4Cl plus magnesium chloride MgCl2, if you heat this entire mixture, then students, in the product side MgNH4PO4, the name of this compound is magnesium ammonium phosphate. Magnesium ammonium phosphate, this is white colored precipitate, white PPT, and including with this 3 moles of HCl also will be formed here, 3 moles of HCl. This is the chemical equation. This formed phosphoric acid can be treated with ammonium chloride and magnesium chloride on heating, then the formed product is magnesium ammonium phosphate white colored precipitate. The precipitates of magnesium ammonium phosphate, again it is filtered, washed and dried and then ignited. Again ignited. Ignited means nothing but heated. Magnesium ammonium phosphate and heated, ignited directly, then students, the compounds are Mg2P2O7, including with ammonia, NH3 and water. And here Mg2P2O7 is the name of the compound magnesium pyrophosphate. Magnesium pyrophosphate, and here NH3 is ammonia, you know that, here is water molecules. And if you balance this chemical equation, here if you place in front of this magnesium ammonium phosphate 2 and here Mg2 means it is balanced. Now before NH3 also if you place 2, the complete equation is balanced. Now the magnesium pyrophosphate thus formed is weighed. The knowing mass of the organic substance is taken and the mass of ammonium phosphomolybdate or magnesium pyrophosphate formed. The percentage of phosphorus can be easily calculated basing upon these two, magnesium pyrophosphate and magnesium ammonium phosphate also. Let's see how the calculation part, how we can do. Phosphorus is estimated as, if phosphorus is estimated as NH4 thrice PO4 12 MoO3. This is the molecular formula of, the name of this compound is ammonium phosphomolybdate. which is in yellow color. So yellow color precipitate, the name of this compound is ammonium phosphomolybdate. Okay, and let the mass of this compound, this organic compound, is taken as W grams. Okay, now mass of ammonium phosphomolybdate formed is X grams. Mass of ammonium phosphomolybdate. Okay, now you can say that 1 mole of NH4 thrice PO4 12 MoO3 ammonium phosphomolybdate. 1 mole of ammonium phosphomolybdate contain 1 gram atom of phosphorus, that is 3 into 14 plus 4 plus 31 plus 4 into 16 plus 12, 96 plus 3 into 16, 96 plus 3 into 16. Okay, this is from this complete molecular formula. Basing upon the molecular masses here, 3 means NH4, this nitrogen and hydrogen, these two completely NH4 compounds are 3, so 3 into. Then 14 means nitrogen atomic mass is 14 plus here 4 are the hydrogens. Okay, and coming to phosphorus, here atomic mass is 31 and here 4 atoms of oxygen, so 4 into 16 is the atomic mass and 12 into 96 is the atomic mass of molybdenum and 3 into 16 is the atomic mass of oxygen, right? And if you do simple calculation for this, you should get the number 1877 as an answer. Grams of, and these many grams of ammonium phosphomolybdate contain the phosphorus is how many grams, students? Here 31, only 31 grams. Now therefore what we can say, X grams of this ammonium phosphomolybdate O3 will contain the phosphorus should be calculated by 31 into X by 1877 grams. Okay, this is the mass of phosphorus present in W grams of the compound. Now the percentage of phosphorus can be calculated by the formula 31 into X by 1877 into 100 by W. Okay, and the percentage of phosphorus here you can see 31 by 1877 into mass of ammonium phosphomolybdate by mass of the substance what we have taken into 100. Okay, alternatively, if phosphorus is estimated as, for suppose Mg2 P2O7 magnesium pyrophosphate, then now from this the mass of magnesium pyrophosphate is formed is equal to X grams. Now basing upon this you can say 1 mole of magnesium pyrophosphate Mg2O P2O7 contains 2 gram atoms of phosphorus. Okay, now from this molecular formula you need to write basing upon the atomic masses. From magnesium, here 2 magnesium atoms are there, then 24 into 2 31 is the atomic mass of phosphorus here, then 2 phosphorus atoms are present, so into 2, then plus oxygen. Oxygen atomic mass is 16 into 7. Okay, if you simplify this, you should get 222 grams of magnesium pyrophosphate. It is containing, here you can see easily, here is the 62 grams, so simply you can say 62 grams of phosphorus. Here you can say magnesium pyrophosphate P2O7 contain phosphorus amount is 62 grams. Okay, therefore x grams of magnesium pyrophosphate will contain the phosphorus amount should be 62x by what you should get the number 222 grams. Okay, this is the mass of phosphorus present in W grams of the organic compound. Now let's see the percentage of phosphorus present in the organic compound. Percentage of phosphorus is, you can calculate like this, 62 into x by 222 into 100 by W. Okay, basing upon this, we need to write the final formula, general formula to calculate the percentage of phosphorus here. 62 by 222 into mass of, the total mass of magnesium pyrophosphate Mg2P2O7 is formed by the total mass of the substance we have taken. Mass of the substance into 100. Okay, basing upon this, you need to calculate the final percentage of the phosphorus. Let's see the example how we can calculate the total percentage of phosphorus of the organic compound. Here we have the question. 0.12 grams of an organic compound containing phosphorus gave 0.22 grams of magnesium pyrophosphate. By the usual analysis, calculate the percentage of phosphorus in the particular organic compound. Let's see the solution of this question. Here the mass of the compound is taken as, mass of the compound is, starting they have given mass of the compound 0.12 grams. Right, now the mass of magnesium pyrophosphate is formed. Now the mass of Mg2P2O7 is 0.22 grams. Now 1 mole of magnesium pyrophosphate, 1 mole of magnesium pyrophosphate is equal to 2 grams of atoms of phosphorus, or from this you can say 2 into 24 plus 2 into 31 plus 16 into 7. Okay, basing upon the molecular masses. Now finally you should get 62 grams of phosphorus. Okay, this is the 62 grams of phosphorus. That is, it indicates 222 grams of magnesium pyrophosphate contains, the phosphorus amount is 62 grams. Therefore 0.22 grams of magnesium pyrophosphate will contain, the phosphorus should be the formula 62 by 222 into 0.22 grams. Okay, but this is the amount of phosphorus present in only 0.12 grams of organic compound what they have given in the question itself. Therefore the percentage of phosphorus, it can be calculated by 62 by 222 into 0.22 by 0.12 into 100. So the approximate value by doing simple calculation of this, 51.20. Finally, we should get this answer from the question of estimation of phosphorus. Here the calculation of percentage of phosphorus in the specific organic compound, this is the calculation part. Okay students, this is about the estimation of phosphorus and various types of chemical reactions and which element is oxidized into which compounds, those everything I explained to you. Now students, in this session the next topic is estimation of oxygen. Okay, estimation of oxygen. Most probably the percentage of oxygen in an organic compound is usually calculated by the difference method. Okay, let's see what is the difference method. For this, the percentage of all the elements present in the organic compound are added and the sum of this all elements can be subtracted by 100. Okay, subtracted from this 100. Let's see now, if you want to calculate the percentage of oxygen, here you can see 100 minus the sum of the percentage of all other elements. First of all, you have to do that sum of the percentage of all other elements. After that, you need to subtract that total number from the number 100. However, oxygen can be directly estimated. Let's see now. A known mass of an organic compound is decomposed by heating in a stream of nitrogen gas. The mixture of gaseous products including oxygen thus formed is passed over red hot coke at 1373 Kelvin. When all the oxygen is converted into carbon monoxide, that is CO, the mixture is then passed through warm iodine pentoxide, that is I2O5. When carbon monoxide CO is oxidized into carbon dioxide, here liberating iodine. The various reactions involved are C plus O2. Here you need to follow 1373 Kelvin heat and this can be oxidized into 2CO. Here 2 carbon atoms. This is the equation, and I2O5 iodine pentoxide to this, if you add carbon monoxide, then I2 can be liberated plus CO2. Now and plus CO2. You need to balance this chemical equation. Here if you place 5 and here also 5, now it is balanced. Now students, from this, if you multiply this complete equation with 5 and here with 2, now 5 into 2, 10 carbons plus here 5 into O2, 5 O2 plus 2 into I2O3, 2 I2O3, O5, I2O5, then 10 CO2 plus 2 I2, or this can be represented like this: 5 O2, 10 CO2, 12, 2 I2. By knowing the mass of iodine liberated or CO2 is formed, the percentage of oxygen in the organic compound can be calculated very easily. Let's see the calculation part here. Let the mass of the organic compound is taken as W grams. Here the mass of the organic compound, and mass of CO2 is formed. Mass of the formed CO2, it can be X grams. Okay. From, as we discussed previously, from this we can say oxygen, here CO2, and 1/5 of I2 iodine. So here this is considered as equation 1, and from this equation 1 we can say that 1 gram of oxygen, here 1 gram of oxygen present in the organic compound produces 1 mole of CO2. Here is the 1 mole of CO2. Okay, that is 44 grams of CO2 contains oxygen is 16 grams. These two are 1 mole only. Therefore, X grams of CO2 will contain the oxygen should be 16 by 44 into X grams. Okay, this is the mass of oxygen present in W grams of the organic compound. Therefore, the percentage of oxygen, let's see, 16 by 44 into X by W into 100. Okay, or the percentage of oxygen should be written as 16 by 44 into mass of the CO2 formed by mass of the substance what we have taken into 100. Okay, by using this formula you need to calculate the total percentage of oxygen. Okay students, these days the elements of carbon, hydrogen and nitrogen present in the organic compound are determined by atomic analyzer that is called CHN elemental analyzer. Okay, and this analyzer requires 1 to 3 milligrams of the compound and displays the values on a screen within the few minutes. These results are generally accurate within plus or minus 0.03% of error. A detailed discussion let's see in our next session. Okay students, this is about estimation of oxygen. What is the general formula you need to have for the calculation of percentage of oxygen and estimation of phosphorus here, and what are the chemical changes, what is the complete chemical reactions and mechanism also I have explained to you in this session. Right, and this is about our today's session. What is your opinion and what is your view also I would like to know, and please convey in the comment section. If you have any doubt also convey in the comment section. If you like this class, if you understand this class, please subscribe and click the bell icon for my further updates. Thanks for watching.